All right, hello, welcome to 9.6 Notes. This is Mr. Goodrow. Um, I'm coming to you from the studio where we're going to be talking about 9.6. This is a great section to start off these online notes because it ties into what we have been doing very nicely. 9.6, we are applying trig. Well, let's do a very simple 9.5 refresher. 9.5, quick little refresher warm up, was this. It was trigonometric functions. It was the sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the adjacent side over the hypotenuse. And then finally, the tangent of an angle is equal to the opposite over adjacent. These are three different functions that we used to solve right triangle problems. So for example, I'm going to draw this. Let's say we have a right triangle here, and let's give this angle 42 degrees. Let's say we have the hypotenuse as 15, and we are looking for this side. We're looking for this side. We can call it X, we can call it A. If it meant something, a word problem, we could use a variable that helped us remember what that is. So we have those things. We know this is a right triangle, that's part of it. And we have an angle, we have a hypotenuse, we have a side. If we have any two pieces, then we can solve for the rest. In this case, I'm going to be starting from this 42, that's my angle, and wherever angle I pick is going to determine which one of these I use. So I have the hypotenuse, that's good. So because I have the hypotenuse, I know that I'm not going to be using tangent. This one doesn't use hypotenuse, so I know I'm not going to use that. I'm going to be using sine or cosine. I also am looking for the adjacent side. I'm looking for the adjacent side, which means in this question, I'm going to be using the cosine. There are times when we have the opposite, that's when we use sine, but right now I do not care about the opposite. I'm not looking for it, I don't have it, so that's a good indicator I won't be using it. I'm going to be using the hypotenuse and the adjacent, which means I have to use the cosine. So the cosine of an angle, that's 42 degrees, equals my mystery number over 15. If you remember when we talked about in class, this is just a number. This is a ratio. Some classes I talked about how to use a calculator. Other classes I did not. You have a sheet where you can scroll down the A column until you get to 42, go to the cosine column, and then see what decimal you get. If you have a calculator, here's what you're going to want to do. First and most important is click this mode button. This mode button is going to bring up all these different functions. We don't care about most of them, but we do care about one that's called radians and degrees. For me, it's the fourth one down. For a lot of people, it's the third one down. I'm going to set it to degrees. Go to degrees, press enter, and then I can quit. I can just press clear, I can press second mode, whatever you do, just get out of it. Now that you've done that, you can use your calculator to solve this in a lot easier fashion. Cosine of 42. I'm going to click the cosine button, that's right here in the middle of the screen. Click 42, and I get a decimal. If you are doing this on your paper, you're going to get the same decimal just about, 7431. And what that is, remember, all these are people who have figured out how each of these triangles, right triangles, work. So every time we have a 42, 48, 90 triangle, this side is always going to be about 74% the size of the hypotenuse. That's all that's happening. I'm going to multiply both sides by 15, and then we have our answer. x is around 11.1. That is our 9-5 review. So those are all the things we've done before. We've also worked backwards and found an angle, but make sure you feel comfortable with that. You've had some homework problems that I hope you look at to help you feel more solid. Because 9-6, what we are doing today, all it is taking 9-5 and applying it in places, using these exact same things. So you don't need to know very much more. I'm going to teach you 2 new terms, and then we will apply them. So here are the 2 new terms you need to write down. The 2 new terms you need to write down are something called angle of elevation and angle of depression. This is a way of talking about angles in the real world when you don't have a nice clean grid. Angle of elevation and angle of depression are both starting at the horizon. They're both starting going side to side. I like to imagine a person looking out somewhere. So imagine somebody looking, that's their eyesight, like if they're Cyclops from the X-Men, they're shooting laser beams. Angle of elevation is what it means when you start from here and you go up. So if you're looking up, you went a certain amount of elevation to go from flat, looking straight across, to go up. So maybe you have an angle of elevation of 20 degrees. Maybe you looked up 20 degrees. Conversely, angle of depression is you're taking your eyesight from horizontal and you're going down. So for example, maybe you're looking down at, you're on the Eiffel Tower and you're looking at the people walking around. Maybe you have an angle of depression of 30 degrees. Angle of elevation and angle of depression are just 2 ways to talk about how we find angles in the real world when we're using our space that we like to use to understand how things are going. So make sure you understand those 2 concepts, because those are the keys to solving the problems we're going to do today. We're only going to do 2 problems, 1 of each. So make sure you understand that idea, because this part is how we solve problems in this section. Angle of elevation goes up, angle of depression goes down. Now, I'm going to do this. We're going to start with our first problem of 2. The reason is they're a little bit longer, and I want to go in depth and take some time. So I would like, I'm going to read it out loud, and then I want you to pause the video until you write the whole thing down so you have it as well. Remember, we're only doing 2 problems from 9-6 because it's the same content, just with words instead of a simple abstract drawing. AJ is flying his drone at the park. He spots the drone at an angle of elevation of about 30 degrees. The drone is 102 feet off the ground. If AJ is 6 feet tall, how far is the drone from him? So pause the video and copy that down. Okay, well, welcome back. There's a couple key pieces of information in the instructions that if we don't get now, it's going to make solving it very hard. We have the angle of elevation. It's 30 degrees. This is about, but we'll say it's 30 degrees. We have how high the drone is. We're also given how tall AJ is. Now, the number one thing I want to tell you to solve these problems, the number one thing that I want you to do when you're solving these problems is draw a picture. It doesn't have to be a good picture, but any sort of graphical representation to help us solve it. Because for a few reasons, this is a lot easier for us to solve than this. When we look at this, our brain doesn't immediately see what's going on. So if we can take this into a picture and then math the picture, we'd be happy. So we have AJ. He's flying his drone. We'll give him a little controller. And his drone is up here. You don't have to draw things. Now understand, all of these problems we are doing are going to be right triangle problems. Finding out where is the right triangle in the problem is a very good question to be asking. We have AJ, he's flying his drone, and we have a couple pieces of information. Now all I'm going to do is take these three things we were given and plug them in. There are three things and plug them in. We know the angle of elevation is 30 degrees. So I start from horizontal, I start at his eye level, and I go up. This is 30 degrees. The bottom left corner is 30 degrees. That's what that means. That is where we're getting that information. That's why it's so critical. We know the drone is 102 feet off the ground. So this isn't 102 feet because this is his eyesight. His eyes are not on the ground. He's not laying army style. So we know this height is 102 feet. And lastly, we know his eyes are 6 feet off the ground. Okay, that is all the information we have from the question. If we were given this instead of this, it'd be a little easier problem. Our first step is to draw a picture. Pause the video if you need to draw your own picture, if you need to fix yours. Hopefully you can see what we're about to do with this. What I'm going to do is simplify our picture over here. I'm going to turn it into a math drawing because some days we're just still more comfortable solving a very abstract shape than not. We know this is 30. All I'm going to do is change this whole drawing into a very small triangle. I am looking for the hypotenuse, right? I'm looking for how far away it is from him. That wasn't directly stated. It was the hypotenuse or that was horizontal. I'm telling you it's the hypotenuse this time. We know he's 6 feet tall, but I'm not going to put a 6 here. What I'm going to do is make the height 102 minus 6. 102 minus 6 for 96. This part of my triangle, from the drone to his eyes, is 96 feet because 102 goes to the ground. So what I'm going to do is solve this triangle. I'm going to solve this triangle where I have a 30, 96 feet, and a hypotenuse. Well, if you remember our little process to figure out what we're going to do, this is now a 9-5 problem, an abstracted 9-5 problem. 30, I'm looking at the opposite side. I don't have the adjacent side. And I want to find the hypotenuse. If I have opposite and hypotenuse, I'm going to use the sine. The sine of 30 equals 96 over h. 96 over h. Sine of 30, that is just a decimal. You can go to your sheet, go down to the 30th row. I'm going to click sine of 30, and I get 0.5. That's a very clean decimal, and if you don't remember, we talked about 30, 60, 90s before. And this is our S basically, and this is our 2S. That's what's going on. So we have 96 and H. If I want to solve for H, I can just swap places of it. 96 cut and divided by a half is going to be double 96. The hypotenuse in this case is 192 feet. That is how far away he is from the drone. Make sure you understand how we went through this whole process. The process of it is not very complicated. It's kind of 3 steps. First step isn't really draw a picture. First step is kind of gather your information. What are the things in the question that I need? If you see a number, if it's a question I have written, please assume you'll use that number. If you do it on homework from the book, they may give you things you don't need. But if I give you a question, especially if you're learning this remotely, as you are right now, if you see a number in here, that's a good indication it's going to be used. I won't give you anything you don't need. From those, I drew a picture. I drew just a simple little diagram to kind of understand what's going on. I drew my angle of elevation. I've added that this is 102 feet to the ground, but I see the triangle I'm making is from his eyes. The eyes are the window to the soul, so that's why we're using that. I turned it into a very simple diagram, and I solved it from there. Okay, that is question 1. If you need to pause the video to finish copying anything down, please do. Okay, let's go on to question 2. Question 2 of 2 for the day. This will be our last one for our first part of 9-6. This is only part 1. We will get into some very complicated things, but this is the most I want you to focus on. I'm going to read this one. Afterwards, I would like you to pause it. Make sure you write it all down. Allie's apartment is 30 feet in height and looks down at a fire hydrant at an angle of depression of 40 degrees. What is the horizontal distance from the building to the fire hydrant? Let me grab a color and we'll start marking it up. So the apartment is 30 feet in height. We have looking down with an angle of depression of 40 degrees. I'm always looking for an angle of depression or elevation. If I don't have that, I'm probably solving for it. And then that's it. What is the horizontal distance? This is another great time to draw a picture. We will draw a picture to sort of see what this looks like as best we can. I'm going to draw a very simple building, draw a little window over here, and draw a fire hydrant. I'll draw a red one just because thematically they normally are red. Okay. We're looking down from the window. So here is Allie. She is standing in the window. Remember our angle of depression. This is the hardest part to remember. The angle of depression comes from her eyesight. So she is looking right here at this fire hydrant from that angle there to 40 degrees. So where's the right triangle we are solving? We want the horizontal distance from the building to the fire hydrant. So this is the right triangle we are solving. Astute observers will notice the 40 is not in there. The 40 is not in there. The 40 is this angle up here, not this one. We have a couple options. We could turn this into 50. This is a complementary angle, so these two add up to 90. We could put 50 right here, but what I would recommend instead is using the alternate interior and writing 40 down here. So the hard part about this section, the angle of depression, angle of elevation, they actually both end up in the same location. They both end up in the bottom of the triangle, on the flat part of the triangle on the horizon line. One because of alternate interiors, and one because that's just where it is. We know this is 30 feet in height, and we are looking for this. We have no use of the tangent. Of the hypotenuse, so I'm going to use the tangent. I'm going to use the tangent. The tangent of 40 degrees is the opposite of the 40 is over here, because we're using this one. If you did 50 up here, it'd be a little different, but I'm taking this 40, alternate interior in here, and the adjacent tangent is opposite over adjacent, 30 over x. I don't know what, I'll just use x for a variable. And then I just solve this problem. 0.8390. And as you can see, we drew a picture. I could have drawn my simplified triangle. I did not. It would look something like this, where this is 40, this is x, and this is 30. From here, swap those. X is going to be 30 over 8390. So x is something around 35.8 feet. All right, so that is the beginning of 9-6. We will dig even deeper into that, especially honors. Honors, you will have a whole another combination of all this. But this is the idea, taking what we've done in 9-5, and we're looking for two new terms, one or the other, angle of elevation or angle of depression. If we have an angle of elevation, we're going to be starting at the horizon line and going up. If we have an angle of depression, we're going to have the horizon line going down. But that can come to the bottom corner because of alternate interior angles. We are looking for a right triangle. We're looking to make a simple 9-5 problem. We're looking to make something simple like what we have done out of the words we're given. So you should have some practice problems that you're going to do, and I will see you at the next notes. Thank you.